Hello, and welcome to Module 2 of this course called Mastering Continuous Threat Exposure Management, a proactive security solution with Microsoft Defender for cloud and security exposure management. For everyone new to the channel, my name is Julio, and I am very happy that you're watching this video. Back in Module 1, we covered the basics of Continuous Threat Exposure Management, CTEM for short. If you missed Module 1, I encourage you to watch it. The link is the description below. In a nutshell, CTEM is a sort of framework that creates the foundation for a proactive cybersecurity approach that continuously identifies, prioritizes, and mitigates risks across your digital landscape. The goal is to reduce exposure before attackers can exploit it. Today, in Module 2, we're jumping into what's arguably the most important phase of the CTEM lifecycle. That is the discovery phase. Before anything, the very first task is to map your entire digital estate comprehensively, making sure you have a complete inventory of all your assets, both the ones you know about and the ones that might be hiding. Here's the thing. The importance of a complete asset inventory cannot be overstated. It is the foundation for an effective continuous threat exposure management. Think about it this way. You can't protect what you don't know you have. Every asset that remains undiscovered creates a dangerous blind spot in your security posture. It's like leaving a door unlocked that attackers can potentially walk right through. The entire notion of proactive approach is based and requires a full understanding of your digital footprint to work properly. Without any further ado, let's dive right into the details. Let's start with a question. Why is this so critical today? Well, we're dealing with several significant challenges that make continuous discovery more important than ever. To start, our dynamic cloud environments pose the first major challenge. Cloud platforms like Azure, AWS, and GCP have made environments incredibly complex and dynamic. Resources are constantly being created, spun up or down, reconfigured, and changed at breakneck speed. Think about auto-scaling groups that provision new virtual machines based on demand, or serverless functions that exist only when triggered. Our traditional security assessments just can't keep up with this constant movement. If your asset inventory isn't continuous and updated in real time, you'll always be playing catch-up, missing newly provisioned resources or critical changes to existing ones. The second challenge involves expanding attack surfaces. Hybrid and multi-cloud environments are pretty much the standard now, which means your organization's attack surface is massive and constantly shifting. This surface includes every digital asset your organization owns or uses. We're talking about on-premises servers, cloud-based virtual machines, containers, databases like Azure SQL or AWS RDS, serverless functions, web applications, storage accounts, network devices, identities, and code repositories. Attackers are always looking for new ways in, and every uncatalogued asset might be their next entry point. Without a complete inventory, you risk overlooking critical access points that could lead to unexpected breach scenarios. Then there's the proliferation of threats. The threat landscape itself is evolving at an alarming rate. New and increasingly sophisticated exploits are being released constantly. Attackers use new techniques and zero-day vulnerabilities that can target any exposed asset. Without understanding all your assets, it's impossible to know which ones are exposed to these emerging threats and where your most critical vulnerabilities actually lie. You simply can't defend against threats targeting assets you don't even know exist. This continuous discovery process helps safeguard your valuable assets from various threats and risks. A complete inventory forms the foundation on which you can truly enhance your security posture and improve overall organizational resilience. If an asset remains undiscovered, it won't be included in security assessments. Its risks won't be prioritized, and any vulnerabilities it might have won't be remediated. Therefore, a comprehensive inventory is crucial because all subsequent CTEM phases like assessment, prioritization, remediation, and optimization are incomplete and less effective without it. A gap in discovery inevitably means a gap in your overall security. For assessment phase, if an asset is missing from inventory, it won't be scanned for vulnerabilities or misconfigurations. Next, for prioritization, risks associated with undiscovered assets can't be assessed or prioritized, leaving critical exposures unaddressed. With remediation, you can't fix vulnerabilities on assets you don't know exist. And regarding optimization, without the full picture, security improvements can't be accurately measured, and the attack surface might not actually shrink. So, let me repeat the main concept again here. The discovery phase focuses on identifying all your digital assets and workloads across your entire environment. This needs to include everything from your Azure resources to AWS accounts, GCP projects, and on-premises machines. It must encompass both known assets that are formally provisioned and managed and the unknowns, which could be shadow IT or publicly exposed assets that your organization might not be aware of. And talking about the unknowns and shadow IT, publicly exposed assets, do you have any idea how many generative little applications and agents are provisioned in a typical organization environment? Are these just test apps or prod services that various business units might decide to develop for their operation without proper approval, or simply reporting them to the DevOps and security team? A Boston Consulting Group study found that 54% of workers would use AI tools at work without company authorization. Other reports indicate that anywhere from 50% to 75% of employees use unapproved AI tools. A study by Fishbowl found that 68% of employees who use AI tools do so without informing their superiors or the IT department. A Netscope report found that the median number of generative AI applications used by an organization more than tripled in 1 year, from 3 to over 9.6 applications. For some organizations, the number can be much higher, with the top 25% of companies using up to 24 different applications. Employees often turn to unsanctioned tools because they are faster or because they find the company's approved tools inadequate. They are simply trying to be more productive. The unmonitored use of these tools poses major risks. A survey found that 93% of employees admit to inputting information into AI tools without approval, and a significant portion of that data is confidential. Gartner predicts that by 2027, 75% of employees will acquire, modify, or create technology outside of IT's visibility. The unknown, external assets are particularly concerning, and we'll explore how to discover them with solutions like Microsoft Defender External Attack Surface Management later in this module. Microsoft provides powerful tools that work together to offer a comprehensive discovery experience. Microsoft Defender for Cloud acts as a central hub for achieving a unified inventory of your Azure, AWS, GCP, and on-premises resources. As a cloud-native application protection platform, it provides unified security management and advanced threat protection across these diverse environments. Even its foundational CSPM plan, which is free, offers a solid asset inventory, secure score, and regulatory compliance with the Microsoft Cloud Security Benchmark. This unified view gives security teams a single pane of glass for their diverse digital estate. Microsoft Security Exposure Management takes things up a notch. While Defender for Cloud provides internal inventory capabilities, Security Exposure Management builds an enterprise exposure graph. This graph is potentially a game changer, gathering and normalizing diverse asset information, including devices, identities, machines, and storage to create a comprehensive, interconnected view of your entire digital estate. Security Exposure Management enriches raw asset data with critical security context, allowing you to proactively manage attack surfaces, protect critical assets, and explore exposure risks more effectively. While Defender for Cloud offers an inside-out view of your managed resources, Microsoft Defender External Attack Surface Management performs outside in scans to discover publicly exposed digital assets that your organization might not even be aware of, essentially mapping your external attack surface. This helps uncover potential shadow IT or forgotten internet-facing resources. For achieving a truly comprehensive view of your security posture, security exposure management can integrate data from various external third-party security and asset management products. You're not limited to Microsoft's tools. Security exposure management integrates with well-known solutions including Qualys, which can retrieve data on compute devices and crucial vulnerability findings identified by Qualys. Tenable Vulnerability Management allows security exposure management to ingest vulnerability data specifically for CVEs reported by Tenable on your assets. ServiceNow ComDB integration is particularly useful for enriching asset details with business application or operational affiliation data alongside general asset information and security context. Rapid7 Insight VM contributes vulnerability and asset data to the exposure graph. When data from these external connectors is ingested into security exposure management, it undergoes normalization within the enterprise exposure graph, creating a consistent and unified data model. This results in an enhanced device inventory that displays the discovery sources for each asset, allowing you to filter and view devices discovered by various Microsoft or external tools. The synergy between Defender for Cloud Inside Out View and the Microsoft Defender External Attack Surface Management Outside In Perspective, along with the Security Exposure Management's ability to aggregate and contextualize all this data within its enterprise exposure graph, provides the end-to-end continuous threat exposure management experience. The foundational cloud security posture management plan in Defender for Cloud, which is free and enabled by default when you set up Defender for Cloud, already offers a solid asset inventory. This foundational plan includes features like a secure score, regulatory compliance with the Microsoft Cloud Security Benchmark, and the comprehensive asset inventory we're discussing. However, to have a complete picture of the contextualized risk, it is recommended to enable the premium CSPM plan. That is the Defender CSPM. Now, let's consider your multi-cloud environments, specifically Amazon AWS and Google GCP. Defender for Cloud extends its reach to other major cloud providers through dedicated connectors. This ensures that your cloud security posture management and cloud workload protection platform solutions can span across all your cloud environments. For AWS accounts, you can connect them to Defender for Cloud and have a unified view of your AWS resources and security findings directly within Defender for Cloud. The connection process involves deploying a CloudFormation template to your AWS account. This template creates the necessary resources and roles for Defender for Cloud to discover and assess your assets. Defender for Cloud then monitors resources such as EC2 instances, S3 buckets, RDS databases, and EKS clusters. For effective discovery, specific IAM permissions are required. They include various actions for describe and list services across the environment, like application programming, interface gateway, CloudFormation, CloudFront, CloudTrail, CloudWatch, and config service. These requests are read only and generally don't incur charges, but they are registered in CloudTrail if you have enabled a trail for read events. You can also configure the scan interval for your AWS environment with options ranging from 4, 6, 12, or 24 hours, with 12 hours being the default. For GCP projects, like for AWS, you can similarly connect your GCP projects to Defender for Cloud. This integration provides a unified view of your GCP resources and security findings directly within Defender for Cloud. The connection process for GCP typically involves running a gcloud script to configure necessary access. The script is auto-generated by Defender for Cloud based on your connection configuration, and it creates essential resources on your GCP environment, including a workload identity pool, workload identity provider, service accounts, and project-level policy bindings. The integration supports the discovery of resources like Google Compute Engine, virtual machines, GCP storage buckets, GKE clusters, and Cloud SQL instances. To enable discovery and authentication, certain GCP application programming interface must be enabled. Here, some of these. So here, let's do a quick demo on how you will connect either AWS or GCP to Defender for Cloud. So we are at the Microsoft Defender for Cloud main page. In order to add the AWS account or organizations or the GCP projects, you are need to go to the environment settings. Under the environment settings, there is this section called Add Environment. You click the drop down and you have a bunch of environments that you can add into Defender for Cloud. We are interested into the Amazon Web Services, the AWS, or the GCP Cloud. Those are the connectors that you will use in order to onboard AWS accounts or GCP project into Defender for Cloud. So the experience is very much the same, but let's do one at a time and let's just walk you through the wizard. So for Amazon Web Service, you click it and you will have the wizard for the connector starting with the general account details. You provide a connector name, AWS account 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1. Oops, too long. Let's short them up. Account 0, 1. You have an option to select different regions where this account is selected to be discovered pretty much, or you can select them all if you need to. You need a resource group because the connector will be created as an object in Azure. So this object will live as a resource inside of Azure under resource group. You can choose anything or create a new one. I'm going to choose something that already have it. I'm just going to do like a resource group that already have it. You can select the region where this connector is going to be located inside of the Azure. Obviously, it's very much associated with the resource group. You have a scan interval, which I mentioned already can go from, which can go from 4, 6, 12, 24 hours. By default, it's 12 hours. So you can keep it that way if you're, select the desired interval. You need the AWS account ID. I'm just going to use a fake one, 0, 1, 2, 3, 4, 5, 6, 7, 8, 1, 0, 2, 1, 0 actually. If you have, because we are onboarding the entire management group, the entire management account, you can choose to exclude some of those accounts and you can actually add those accounts IDs separated by colon. Otherwise, you can just go with one single account. The difference is that, for the single account, you're only onboarding that account. With the management account selection, you onboard the entire management account and then all the single AWS account under the management group. Okay. Next, you need to select the plan. By default, all the plans are enabled, but I highly recommend that you select obviously all of them. You have Defender CSPM. The foundational is already enabled by default. There's nothing that you really need to do. This Defender CSPM is highly recommended you enable. You have servers, database, and containers you can enable. Next is based on the selection that you can choose to create the configuration, either default access or the least privilege access. If I want to do least privilege access, I select that. You also have an options to use the AWS Cloud Formations or the Terraform. Let's say I want to use the AWS Cloud Formation. At this point, what I need to do, I need to make sure that everything is here is correct by, if I need it, I can customize some of the roles. They are going to be created under the ARA names. I can do that. And then I can basically download the AWS Foundation Stack and then log on the AWS Formation Stack portal, and then you need to execute it.
You have to make sure that it's executed successfully, that the template has ran successfully on AWS side. And then you can basically go the next stage, which is just review and create. Once, if everything has been done correctly, even the template has been executed on the AWS side that you created, it creates the actual resource inside of the Azure as a connectors. On the other hand, on the AWS accounts, you have a bunch of identities and created and configuration set it. Therefore, in about 12 to 24 hours, you have a full discovery of those environments. If you select server containers, then you also have the installation of the Arc agent will then onboard those servers and containers under the Azure and obviously under the Defender for Cloud threat protection plan. Now, I'm not going to create this. If you decide to do the same thing for the GCP, the concept is the same. The only different here is the actual configuration that you are required to run under GCP. So let's do again organization ID if you want to port the organization ID, or if you want a single project, same thing like AWS does. You have the same exactly what do you call it? Defender for Cloud plans that are available. Same as the AWS, they're already enabled. And if you go in the configuration act, that's where the change is. What is different from AWS? Here you have the Cloud Shell. You still have the Terraform, but now you have the Cloud Shell. So based on your configuration, we provided a Cloud Shell script, which you can do it. You can copy basically from here. Instead of download it, you copy, log in on the GCP Cloud Shell, and execute that script. Once the script is completed and successfully executed, then you can go next and generate the create for the connector. Just like before, the actual connector within the Azure gets created as a resource. On the GCP, the initial configuration will take place. Therefore, there will be a scan, discovery, and then installation, the Arc agent, and then the assessment run for the security posture and so on and so forth. And with this, we just basically show you a quick demo how to add those multi-cloud connector in Defender for Cloud.
Almost 2 decades have passed by since cloud computing was first introduced. Since then, it has indeed become the default for all organizations. However, many, if not almost all, still have some on-premises resources. These resources cannot be left unprotected. The good news is that they also get coverage through Defender for Cloud, which offers protection for your on-premises machines, bridging the gap between your cloud and local infrastructure. To protect on-premises machines, you can connect them to Azure using Azure Arc-enabled servers. This mechanism allows Defender for Cloud to treat your on-premises Windows and Linux machines as Azure resources, extending its full security capabilities to them, including Defender for Servers, Kubernetes, and Defender for CKL on machines. The Azure Arc agent is crucial for collecting security information from these hosts and enabling the deployment of other necessary agents or extensions. While historically, the Log Analytics agent or Azure Monitor agent collected data from these machines, Microsoft has phased out this dependency. Currently, Defender for Servers features rely on Microsoft Defender for endpoint integration and for cloud-based virtual machine. Defender for Servers now also provides agentless scanning, ensuring continued comprehensive protection without the need for traditional agents. For those looking to gain hands-on experience, you'll need a Microsoft Azure subscription. You can sign up for a free Azure account, which often includes free credits or a trial period. Microsoft Defender for Cloud offers a free trial for the first 30 days. Though it's worth noting that malware scanning in Defender for Storage is charged from day one, and is not included in this free trial. In the Module 1 of the series, you'll find all the information on how to get an Azure subscription, Entra ID, and related licenses. By bringing all these diverse resources, Azure, AWS, GCP, and on-premises into a unified view, Defender for Cloud empowers security teams with a comprehensive understanding of their entire digital estate. This complete picture is invaluable for your CTEM program, as it ensures all assets are visible, then can be assessed, prioritized, and finally, effectively protected. So, we have discussed how Microsoft Defender for Cloud acts as your central hub for unified asset discovery, providing that crucial inside-out view of your Azure, multi-cloud, and on-premises resources. We saw how it brings everything into a single, cohesive inventory, which is essential for effective continuous threat exposure management. But an inventory, however unified, is just the beginning. To truly achieve a proactive security posture, we need to understand the relationships and potential attack vectors within that inventory. This is where Microsoft Security Exposure Management and its Enterprise Exposure Graph come into play. While Defender for Cloud gives us the detailed information about our assets, Security Exposure Management takes that understanding further by building an Enterprise Exposure Graph. This graph isn't just another list, it's potentially a game changer. It gathers and normalizes diverse asset information to create a comprehensive, interconnected view of your entire digital estate. The Security Exposure Management's core purpose, and that of the Enterprise Exposure Graph, is to provide a unified view of your security posture across all company assets and workloads. It enriches raw asset data with critical security context, which may enable you to proactively manage attack surfaces, protect critical assets, and explore and mitigate exposure risk more effectively. This is vital because in today's dynamic and complex cloud environments, where a static view of assets simply won't be enough, resources are constantly being created, spun up or down, reconfigured, and changed at a rapid pace. Most of traditional static security assessments struggle to keep pace. The organization's attack surface is vast and constantly shifting. Security Exposure Management steps in to transform raw inventory data into actionable security intelligence. It helps various stakeholders, from security and compliance admins responsible for maintaining posture, to SOC teams requiring visibility across organizational silos, and even chief information security officers seeking insights into overall organizational risk. Instead of operating in silos, security teams can now see the intricate web of relationships and potential attack vectors, giving them the context needed for truly proactive security. So, how does this Enterprise Exposure Graph actually work? Let's break it down into its core mechanisms. First, there's data consolidation and aggregation. Security Exposure Management doesn't just collect data once. It continuously aggregates security posture data and insights from multiple sources. This is where the synergy with other Microsoft security solutions really shines. The inside-out view from Microsoft Defender for Cloud, including security posture information, recommendations, alerts, and cloud security posture management findings, is directly ingested into Security Exposure Management. Security Exposure Management also pulls in rich data from Microsoft Defender for Endpoint, Microsoft Defender for Identity, and Microsoft Entra ID. Crucially, it also supports integration with external data sources like Qualys, Tenable Vulnerability Management, Rapid7 Insight VM, and ServiceNow CM, DB. As discussed, this means Security Exposure Management can retrieve data on compute devices, vulnerability findings, and asset information, helping to consolidate vulnerability reports and enrich asset details. This comprehensive ingestion means that Security Exposure Management creates a single, comprehensive source of truth for all your digital assets and their security context, eliminating fragmentation of security data. Once this data is collected, it's processed by the graph-based context engine. The Enterprise Exposure Graph is fundamentally a powerful engine that collects and correlates vast amounts of data from your multi-cloud environment and other sources. It builds a comprehensive, interconnected representation of your digital assets. This interconnected data includes cloud assets inventory, showing what assets you have across Azure, AWS, and GCP. It tracks connections, how assets are logically or physically related to each other, such as a VM connected to a storage account or an identity linked to a device. The system identifies lateral movement possibilities, how an attacker could move from one compromised asset to another within your environment. It maps internet exposure, which assets are publicly accessible from the internet, a key factor in determining risk. Permissions show who has access to what, including user groups and specific access rights. Vulnerabilities represent identified weaknesses in assets that could be exploited by attackers. User groups and identities provide information about the human and non-human identities interacting with your resources. The graph represents your digital estate as nodes and edges. The nodes are the individual entities or objects in your environment, such as devices, identities, user groups, and cloud assets like virtual machines, storage accounts, and containers. Each node encapsulates information about its characteristics, attributes, and security-related insights within the organizational structure. The edges represent the relationships or connections between these entities. For example, an edge might represent that one asset, routes traffic to another resource, or an identity can authenticate as another identity. This highly structured, interconnected model is what allows security exposure management to perform deep contextual analysis far beyond what a flat inventory could offer. By leveraging this intricate and interconnected graph, security exposure management offers several crucial capabilities and benefits for your CTEM program. Attack path analysis stands as the first and foremost capability. Security exposure management is able to generate attack paths by simulating attack scenarios and identifying weaknesses that an attacker could exploit to reach your critical assets. This allows security exposure management to perform sophisticated analysis, potentially finding exploitable paths that might start from an internet. Exposed resource discovered by Defender External Attack Surface Management and lead directly to critical internal assets identified by Defender for Cloud. This helps you visualize how an externally facing misconfiguration or vulnerability could be exploited to compromise your valuable assets. To make these complex relationships digestible, security exposure management provides visualization with the attack surface map. This interactive map allows you to visualize these attack paths and your overall exposure data. It helps you clearly see unwanted connections, internet exposed devices, and potential lateral movement possibilities across your entire digital estate. You can explore assets and their connections, hovering over nodes and edges to get additional information, making it easier to pinpoint critical risks. The map also uses visual indicators, such as a crown icon for high critical asset or a bug icon for a vulnerability, to highlight where critical organizational data is at risk. The graph also helps in identifying choke points and understanding the blast radius. Choke points are critical assets where multiple attack paths intersect. By addressing security issues at these high-impact assets, you can efficiently reduce risk across numerous potential attack paths. The blast radius visualization allows you to explore the potential impact if a choke point or other asset is compromised, helping security teams assess the broader implications of an attack and prioritize mitigation strategies more effectively. This empowers teams to focus on mitigation efforts that may yield the greatest reduction in overall risk. Another key benefit is critical asset protection. Security exposure management streamlines the identification and prioritization of your most valuable and important assets, your crown jewels. You can define custom critical assets and monitor their security resilience through specific initiatives, like the Critical Asset Protection Initiative. This ensures that security efforts are focused where they matter most, potentially maximizing impact on your organization's security posture. Critical asset tagging information is integrated throughout the Defender portal, including in attack paths and the device inventory. visually indicating high criticality with icons like a crown. Finally, for proactive exploration, Defender for Cloud includes risk hunting with the Cloud Security Explorer. This powerful tool integrates with the exposure graph, enabling security admins to proactively hunt for posture issues and uncover hidden connections within their environment using graph-based queries. You can build custom queries or use built-in templates to query for secrets, internet-exposed virtual machines, and other critical insights. This transforms raw data into actionable insights, helping teams to detect vulnerabilities and misconfigurations that might otherwise go unnoticed. If you look into an advanced risk hunting analysis, security exposure management allows to query the data directly from the data tables using KQL. These two tables are the exposure graph edges and nodes, and they are available through Defender XDR advanced threat hunting capabilities.
All right, another demo time. This round, we're going to demo the exposure management. So how do you get access to exposure management? Well, the link is security.microsoft.com. So that's basically the Defender XDR portal that you are going to access. Here, we are already on the XDR portal, and you can see several areas that you can explore. For the sake of this demo, we're just going to look into the exposure management, which is basically the sections right under the home page. We are at the home page already, which already gives you a tons of information related to your environment, mainly driven by the solutions that you have enabled, such as Defender for Cloud, Defender for Endpoint, Defender for Identity, Defender for Cloud Apps, so on and so forth, Sentinel. In order to access exposure management, you can simply expand the exposure management sections. And then under the exposure management, there is obviously the main overview page, which is something that you are accessing on a daily basis to have the main overview of what's happening. Here you have different views. You have the external attack surface protection, the ones that we have mentioned already, the Defender external attack surface management. At this moment, I don't have much of the data because it's barely enabled with just one domain and one host. So there are not really much of insights being provided by those endpoints. However, we have some data regarding the SaaS security. And then we have a benchmark that is being used to assess the M365 applications. The M365 environment. Then we have Zero Trust view, and those are basically the percentage of the sort of score, right? And then we have the cloud security, which is also exposed as in terms of security percentage. Now, from here, I can show you other areas such as critical assets. We discussed about the notion of discovering those assets, and specifically those that have a critical component within your environment. We call those critical assets, and that has a crown jewel icon. There are 7 critical assets in here. If I click on the critical assets management, basically it will take me to the section where you can set them up, the rule for identifying those critical assets, and therefore ensure that they are treated as a critical assets. So back in the overview, you also have the attack surface map where we have 3 devices so far and 6 identities. and then for a total of 43 cloud assets. You can click on the view map, which will take you to the to the bigger view of the map, or you can simply jump on the attack surface by expanding the sections, and there you see also the map and the attack path. Couple other things you can see over the overview page are the top metrics. Like perhaps I have a couple top metrics such as critical virtual machine with the plain text and plain text keys and secrets, missing best practice to manage application there or interact with other application using OAuth protocol. So basically, there are areas where the exposure manager does a security check and then it provides those into a form of metrics and gives you it highlights those that needs to have the major attentions. Now, if we go in the attack surface map, we can see that that small map now is converted into a bigger map. We have 3 devices considered three total devices, and then 6 total identities. In total, everything we have 43 cloud resources. Now, 3 of those identities are considered critical assets, and 4 of those cloud resources are considered critical assets. Now, the other thing you can do here, you can basically go on the attack path. Now, we discussed about the attack path. Now, the attack path is an important factor, and because obviously, proactively, we are indicating potential breach and lateral movement. Okay. The cool thing about this page is that you can easily see the ongoing discovery of those paths over time. Okay. We have from the 13th of August all the way to the 22nd, we have basically around 4 attack paths, and those stay steady until hit the 22nd. Hit the 23rd, where we went from 4 paths to 6 attack paths. Okay, and then as the 27th of August, the number of attack paths still 6. This is actually pretty good. Obviously, in my environment, which is a small environment, the graph itself is very small, very like a linear, or some dips and or highs and stuff like that. But then in a regular real organization environment, this could be multiple number of attack paths moving through the month, right? If you go down below the graph of the attack path over time, we have a few areas where are important to work on it. One is the top 5 choke points, and the other ones are the top 5 attack path scenario. All right, and then you also have summary of what are the top targets and what are the top entry point as well down near. Okay, we know that there are several attack paths that we discover, such as VM with high vulnerabilities or VM with high vulnerabilities and allow lateral movement to a storage with sensitive data, or to a key vault. I believe somewhere around here there is a key vault, yes, or others like moving from one server to the other. Now, it looks like this Win server, the MSDN Win01, is the main entry point due to the risk factors and the vulnerabilities that has been found related to the server. This particular server is exposed on the internet. It's got like high vulnerabilities. Many are RCE, so remote code executions, and it has secrets exposed on the server in plain text. So it's one of the entry points with the most critical security gaps. And then from here, the intruder can easily laterally moved into the other targets, such as a key vault here, or a storage accounts, or another server. Those are basically, the three actually targets in my environment that where the attacker can move from the Win server after the breach, and then extend the attack to the other targets. Okay. Also, you have information about top entry point involved in attack path overall. Still, we have a virtual machine. We have pretty much 6 attack path where this virtual machines is in the entry point. Now, here, if you click on the attack path, you see the list of the attack path, which you can then further explore in detail. Perhaps here there is one says Internet Exposure VM with high vulnerability vulnerabilities allow lateral movement to an Azure storage account. Let's see what it does. So you can click it on it, and then we can look into what's the deal over here. Otherwise, you can choose another one and do the same thing. Let's click on this one for a minute. And then, so here, I'm going to expand this view into a bigger map and then zoom up a little bit. Actually, zoom in a little bit so that it's more visible to you guys. So, as we mentioned during the presentations, we have exposure management has a couple main visual icons that are important to understand. One is the crown jewel icon, like this one as well, which indicates resources considered critical to your organization. And you have the rule to apply and configure customly in order to set that critical evaluation. Then you have that bug. Bug is basically it has a high critical vulnerabilities. Okay, so as we saw from the other views, the server Win01 is the one which is exposed to the internet with the high vulnerability that will be pretty much the breach to go to drive the attacker right into some other targets, such as the other crown jewel, in this case, a storage account that has something on that is very vital because it's considered critical. In order to laterally move into this storage account, he does an hop into another server. And that's how he gets basically the path into the final storage account. Now you can see you can actually click on each one of those items and have more information. So this is a server. You have metadata related to the server. All that information that allows you to understand and detect what kind of server it is. You have a little bit more in detail data, right? Exposing through with the property here, and then you can see all the type of vulnerability that have been found. Okay. Now, if I also click on this crown jewel, in this case, if I click on it, I can also see something about the information related to the storage account, and then you can also see pretty much the same level of metadata alike. Okay, now the one thing that's important to note over here, you might have a plus sign. In this case, we have about 4 those additional plus signs for those resources. So you can actually expand that plus sign, and then what it does, it gives you the visibility of other interconnected what do you call artifacts or files or resources, so on and so forth. by expanding the server Win01, we see that obviously on this server specifically, there are several areas of interest. Number one, there is an IP address, which is considered, you can expand, and that's basically considered, it's actually basically considered external faced public IP address in this case. And then if you look basically here, you get more information about their IP address. If I have that IP part of the external surface, attack surface management, then I will have more information related to this specific item. Then I can see there are software basically that is available on these machines. One thing that I want to also notice, I want to show you that also the server itself has an identity. Okay, you can click it on, and you can see more information about identity. So you can see obviously what kind of identity, it's a system identity, all that. And again, you can see all the data. Then you see the identity principal ID number. And then you also have one thing that has been discovered, the SSH key, the private SSH key. So this private SSH key is a fundamental discovery over here because it allows someone that has gained access to the server to use that key and then remote into this Linux. I know exactly that is for this Linux because it's a demo environment, but obviously the intruder has options to figure out which of the public key generated by this private key is available in the environment that can be access to. Okay, and from here again, it goes into, because as this SSH key, the gist of this demo is the intruder gets through here, use the SSH key, and access this server, which is a Linux machine. You can also expand this Linux machine, or you can expand the identity here. But and then you have other information related to this next this Linux machine. Now, one thing that this Linux machine has in terms of security concern is that the machine itself has a system identity configured. This is a system identity configured, which is all good, but it has permissions that allows to emulate the access into the storage account. And when you click in the storage account, if it opens up, and if you click on the storage account, you can also quickly see that, number one, there is a storage called a container called priv data inside of the storage account blob. And within this priv data, there are sensitive data. Okay, this priv data obviously is considered a critical asset, not only because we set the rule for the critical assets to be the storage account, but also because it contains private security information. Okay, you can expand that, and then every time you see a clause, obviously you can expand. And in this case, there's not really much into it, but you can, by extending that, you also see the correlation with the data sensitivity. And if I click on the data sensitivity, I should be able to see the related information about such findings. Okay, now this is just an example of one attack path exposed through Defender for Cloud in this case, and replicated through exposure management, which also gives you a broader view of how those interconnected resources are actually part of a bigger web of lateral movements. So those are really cool and important part to be considered. So with this, I want to terminate and conclude this demo, and then we are going to go back to the presentation, to the sessions video. Okay, thank you, and I see you in a second inside of the session video. Bye bye.
As we discussed earlier in this module, security exposure management's ability to integrate with external third-party security and asset management products is fundamental to achieving a full comprehensive view. By pulling in data from solutions like Qualys and Tenable for vulnerability findings and ServiceNow CMDB for asset information and business context, security exposure management enriches its enterprise exposure graph. This normalized data is then incorporated into the graph, enhancing the device inventory, revealing new attack paths, and allowing for advanced hunting queries in Custo query language. The device inventory within security exposure management will even display discovery sources for each asset, showing you precisely which tools reported that asset. In essence, the enterprise exposure graph moves beyond the simple list of assets. It provides an intricate, contextual, and actionable understanding of your security posture, bridging the inside-out and outside-in views to empower security teams with the intelligence needed to stay ahead of attackers. This comprehensive approach is central to building a truly proactive and resilient CTEM program. Continuing with our exploration of the discovery phase of the continuous threat exposure management lifecycle, we've established that a comprehensive and continuous inventory of all your digital assets, both known and unknown, is absolutely fundamental to effective security. We explored how Microsoft Defender for Cloud provides that crucial inside-out view, giving us a unified inventory of our managed Azure, multi-cloud, and on-premises resources. We then looked at how Microsoft Security Exposure Management builds on this with its powerful enterprise exposure graph, creating an interconnected web of internal security posture data. Now, it's time to complete that picture by turning our attention to the outside-in perspective with Microsoft Defender External Attack Surface Management. Think about it from an attacker's point of view. They aren't starting from inside your network. They're looking for any publicly accessible entry point. Microsoft Defender External Attack Surface Management is crucial for filling a significant gap in many organizations' security postures. It discovers and understands publicly exposed digital assets that they might not even be aware of. This isn't just about the assets you intentionally expose. It includes forgotten domains, outdated web servers, misconfigured cloud services, or even shadow IT that are accessible from the internet. Attackers continuously scan the internet for such entry points, and Microsoft Defender External Attack Surface Management helps you see your organization through their eyes, effectively mirroring their reconnaissance efforts. So, how does Microsoft Defender External Attack Surface Management achieve this? Its primary function is to continuously discover and map your digital attack surface from an external perspective. It's designed to identify all your internet-facing resources, even those your internal teams might not formally track. This is vital because with today's dynamic cloud environments, resources are constantly being created, changed, or spun up and down, making traditional static security assessments insufficient. Your attack surface is vast and constantly shifting. Microsoft Defender External Attack Surface Management employs Microsoft's advanced crawling technology to identify assets that are related to your known online infrastructure. It doesn't just passively listen for data. It actively scans these assets to discover new connections and potential exposures over time. This capability allows it to build an always-on inventory of your external assets, providing continuous visibility. Discovering digital assets for an always-on inventory means it constantly updates your understanding of what you have exposed. Analyzing and prioritizing risks and threats from an external viewpoint allows you to better prioritize your defenses by understanding what attackers see. Pinpointing attacker. Exposed weaknesses. anywhere and on demand, helps you find those critical vulnerabilities before an attacker does. Gaining visibility into third-party attack surfaces recognizes that your attack surface often extends beyond your direct control to partners or services you rely on. The problem Microsoft Defender External Attack Surface Management solves is significant. The larger and more dynamic your attack surface, the harder it is to protect. Microsoft Defender External Attack Surface Management helps security and IT teams to identify unknowns, prioritize risks, eliminate threats, and extend vulnerability and exposure control beyond the traditional firewall. It uncovers shadow IT, legacy systems, or critical misconfigurations that are internet accessible, but might have completely fallen off your internal radar. Without this outside-in view, you're essentially fighting a war with one eye closed. Now, the real power comes when Microsoft Defender External Attack Surface Management's outside-in view is combined with Defender for Cloud's inside-out data within Microsoft Security Exposure Management. This integration provides a comprehensive and contextualized view of your overall exposure. Here's how this powerful synergy works. Data ingestion means that Microsoft Defender External Attack Surface Management's detailed data is directly incorporated into Security Exposure Management. This gives Security Exposure Management a crucial layer of external context that Defender for Cloud's internal scanning alone cannot provide. Enhanced Attack Path Analysis shows how Security Exposure Management leverages the Cloud Security Graph, which contains rich internal asset data and relationships. This powerful combination allows Security Exposure Management to perform sophisticated attack path analysis, potentially finding exploitable paths that might start from an internet-exposed resources discovered by Microsoft Defender External Attack Surface Management, and lead directly to critical internal assets detected by Defender for Cloud. This helps you understand precisely how an externally facing misconfiguration or vulnerability could be exploited to reach your crown jewels. The unified risk view brings these two perspectives together, combining the detailed internal protection and posture data from Defender for Cloud with Security Exposure Management's broader exposure insights and external attack surface management. Security teams get a more complete and actionable picture of their security risks. This prevents security teams from operating in silos across different cloud providers and security tools as highlighted in Module 1. It bridges the gap between how your security team perceives your assets internally and how an external attacker views your potential entry points. Security Exposure Management further facilitates this with a dedicated initiative. This initiative uses Microsoft Defender External Attack Surface Management to continuously discover and map your digital attack surface, allowing you to assess and manage this specific risk area effectively within the Exposure Management portal. You can even get high-level insights using a predefined set of external assets without needing a full Defender External Attack Surface Management subscription, or connect directly to your Defender External Attack Surface Management subscription for comprehensive analysis. Microsoft Defender External Attack Surface Management's discovery process is quite thorough, identifying a wide array of external assets. It focuses on several key categories to build its comprehensive map, including domains, which are your registered domain names, IP blocks, or addresses representing public IP ranges, and individual addresses associated with your organization. Also, it takes hosts as specific server names or subdomains. All ASN, identifying network blocks registered to your organization, emails as email addresses associated with your infrastructure or personnel, and who is organization data from domain registration records. By integrating all this, Microsoft Defender External Attack Surface Management generates attack surface insights. These insights are created by applying vulnerability and infrastructure data to highlight the key areas of concern for your organization. This capability helps security and IT teams to get a complete picture, prioritize what matters most, and proactively defend against an ever-evolving threat landscape. In essence, Microsoft Defender External Attack Surface Management is your proactive early warning system for everything visible to attackers outside your perimeter. When combined with Defender for cloud and security exposure management, it transforms raw asset data into actionable intelligence, making your CTEM program truly comprehensive and resilient. This foundational step of identifying and understanding your entire attack surface, both inside out and outside in, is vital, and it is non-negotiable if you are looking for an effective modern cybersecurity. In our journey to master continuous threat exposure management, we've already highlighted the absolute necessity of a complete and continuous asset inventory. You simply cannot protect what you do not know you have. Any undiscovered asset creates a blind spot, an open door for attackers. We've seen how Microsoft Defender for Cloud provides an inside-out view, unifying your Azure, AWS, GCP, and on-premises resources. But here's something that might be obvious to most organizations. Very few of us rely solely on a single vendor for all our security needs. You likely have existing investments in various security tools, IT service management platforms, or configuration databases. This is where the next powerful capability comes into play. That is connecting external data sources into Microsoft Security Exposure Management. This integration appears paramount for achieving a truly comprehensive view of your security posture. Why is this so vital? It's about eliminating blind spots and overcoming the fragmentation of security data. Instead of having vulnerability data in one system, asset inventory in another, and threat intelligence scattered elsewhere, security exposure management brings it all together. Let's look at some of the specific third-party integrations that security exposure management supports. Qualys is a well-known leading vulnerability management solution. By integrating Qualys, security exposure management can retrieve valuable data on your compute devices, as well as crucial vulnerability findings, specifically common vulnerabilities and exposures identified on those assets. This helps to consolidate vulnerability reports from a platform you might already be using, bringing those critical insights into security exposure management's unified view. To set up this connection, you'll need the UL of your Qualys instance and credentials for a Qualys user with at least read asset permissions. The Qualys connector ingests details like gateway address, FQDN, IP and MAC addresses, OS information, and Qualys criticality data for your devices. Importantly, it focuses on devices that have been modified within the last 90 days to ensure relevance. Tenable Vulnerability Management is another prominent vulnerability management platform similar to Qualys. Security Exposure Management ingests vulnerability data specifically for CVE, reported by Tenable on your assets. This allows you to centralize your Tenable vulnerability insights directly within Security Exposure Management's broader exposure analysis, ensuring that these critical findings are factored into your overall risk assessment. For connection, you will need Tenable Vulnerability Management, API access, and secret keys, and the user generating these keys typically needs roles like Basic, Scan Operator, Standard, Scan Manager, or Administrator. It retrieves data on compute devices, their network interfaces, and Tenable criticality ratings. Like Qualys, it focuses on devices modified within the last 90 days. It's also worth noting that if you use Tenable Lumen, you can bring in your Tenable Asset Criticality Rating, which further enhances security exposure management's ability to identify and prioritize your most critical assets. Currently, the Tenable connector primarily focuses on CVE data, not all types of vulnerabilities or misconfigurations. ServiceNow CMDB is a widely used IT service management and configuration management database solution. Security Exposure Management integrates with ServiceNow to ingest essential asset information and security context. This integration is incredibly valuable for enriching asset details with business application or operational affiliation data, giving your security teams a clear understanding of the business impact of each asset. To establish this connection, you'll provide your ServiceNow instance host name and credentials using basic authentication. The connector retrieves data on devices active in the last 90 days, including operating system, CPU type, criticality, network adapters, last logged on user, and primary business application associations. It is also worth to mention that Defender for Cloud integrates with ServiceNow. This means you can create and manage service request tickets linked to recommendations directly from Defender for Cloud, streamlining your remediation workflows. The integration is bidirectional and allows for efficient collaboration between security and IT operations teams, with synchronization typically occurring every 24 hours. Rapid7 Insight VM represents another key integration mentioned in our course outline. Similar to Qualys and Tenable, Rapid7 Insight VM contributes to security exposure management's comprehensive view by providing data on compute devices, including machines and virtual machines, as well as vulnerabilities identified by Rapid7 on those devices. This allows security exposure management to incorporate Rapid7's insights into its broader exposure graph. To connect, you'll need the endpoint of your Rapid7 platform API and a key. Microsoft recommends using an organization key over a user key for a more successful connection. The connector retrieves data for devices actively scanned in the last 90 days. Once data from these external connectors is ingested, it undergoes a crucial process within security exposure management. All incoming data, regardless of its source, is normalized and integrated into security exposure management's enterprise exposure graph, creating a consistent and unified data model. This leads to an enhanced device inventory that displays the discovery sources for each asset, allowing you to filter and view devices discovered by various Microsoft or external tools. This enriched data empowers advanced hunting capabilities using Custo query language against the exposure graph tables. Security analysts can perform deep dives, correlating data from various sources to uncover complex attack patterns. You can also visualize these external assets and their relationships within your overall attack surface map, providing critical context for understanding potential attack vectors. By bringing together the inside-out view from Microsoft Defender for Cloud, the outside-in perspective from Microsoft Defender External Attack Surface Management, and the invaluable insights from these diverse external data sources, Security Exposure Management ensures that your CTEM program has the broadest possible context. This comprehensive understanding leads to more accurate risk assessments, better prioritization of threats, and ultimately, a more resilient and proactive security posture. This concludes our deep dive into the discovery phase. In Module 3, we will move on to the assessment phase, exploring how we evaluate the security posture of these comprehensively discovered assets. Thank you for joining me, and I look forward to seeing you in the next module.